So we've seen how to draw the t' and x' axis for a two-observer space-time diagram. We know that t' has a slope of 1 over beta, x' has a slope of beta, and we know how to calibrate, space out the time and space markings on these axes. We can do that either algebraically with this gamma factor that's related to beta, like so, and we can also do it by connecting up hyperbolas. So let's put this all together and work through an example. So to do so, I'm going to use this type of fancy graph paper, which is hyperbolic graph paper. And the origin is down here. So I'm going to start by drawing on a pair of x and t axes. So here are my axes for x and t in the at-rest or in Anna's frame. So in this example, I'm going to assume that Beowulf, the moving frame, is going to go at 2/5, like we did in the other example. So then the t' axis, which I'll draw in blue, that's going to have a slope of 5 over 2. Right? The t' axis, that's the clock. Where's Beowulf's clock? That's the world line of the clock that's moving at a speed of 2 over 5. And what that means is when it goes 2 seconds in the spatial x direction, it takes 5 seconds to do that. So I know that this line has to go through here, 2/5. And so I can draw this on like that. Hopefully this works. Great. So that is my t' axis. And then the x' axis has a slope of 1 over beta, or 5 over 2. So that would go over 5 and up 2. That's 2, 4, 5, up 1, 2. It's going to be that point there. So let's draw this on. All right. So that is x'. So the next thing we need to do is figure out how to calibrate x' and t'. And so we could do that with gamma, or we could do that with hyperbolas. So let me start with a hyperbola way. So here, this is 2 seconds, a space-time interval of 2 seconds, and then the set of all points in space-time follows this hyperbola. So that tells me, all right, I'm tracing this hyperbola along, that this mark here on the t' axis is 2 seconds. And that maybe to get the 4-second mark, I would go to 4 seconds here, follow this hyperbola along, and that would be 4 seconds. And then I can do the same thing here. 2 seconds goes along to 2 seconds here. Remember, we calibrate these the same way. 2 seconds goes along, so that mark there is 2 seconds in x' in the moving frame. 4 go along the hyperbola. All right, so we now have calibrated our t' and x' axis. And the last thing we'll want to do is figure out how to use these axes to read off the space-time coordinates of events. So now that we've drawn our axes, the last step is to figure out how to read points, the coordinates of points, off of a diagram like this. So let's say we have a point on the diagram here. Let's call that space-time event E. And I want to know, what does the at-rest observer think the coordinates are for this? And what about the moving observer, Beowulf? What does he say for these for this event? So first, let's read off the at-rest frame, the unprimed frame. And this we read just like you would read a graph, any old graph. So E, that looks to me like that has a t of 5 and an x of 3. So x equals 3 seconds, t equals 5 seconds. All right. Now, how can we use these funky blue axes to read off the coordinates of E? So it's not exactly what you're expecting. It takes a little getting used to, but once you get used to it, it's no big deal. So let's see. So let's think about what T prime is. T prime is the world line of a clock that's at the origin in Beowulf's frame. So so this is the origin moving along this way. If I had a clock that was at the 2-second mark on the x-axis, or the x prime axis, Beowulf's x-axis, that would also move this way. So you can imagine like Beowulf has a whole bunch of clocks. He's traveling with a clock here, a clock here, a clock here, a clock here, and all those clocks are moving together. And so all of those clocks would make world lines parallel to this. So to figure out the position, what I want to do is not go perpendicularly to here, but go parallel to the T prime. So I'm going to do this, let's see. I'm so afraid I'm going to mess this up. All right. So I would go draw a parallel line, which I drew this dashed line, down to the x prime axis. And that would be my x prime coordinate for this. So that looks like, to me, like it's a little bit less than, oh boy, well, let's see. How am I going to calibrate this? All right, so this is 2. This is 1. That's right where the hyperbola intersects there. So the distance between my two fingernails is 1. So I'm going to say that's maybe about 0.8. So x prime is very roughly 0.8 seconds. Okay, to figure out t, the t prime coordinate, we're going to do a similar thing with parallel lines. All right, so the x prime axis, that's the set of all space-time events that are simultaneous with the origin, time equals 0. If I drew a line this way, that would be the set of all space-time events in Beowulf's frame that's simultaneous with 2 seconds. If I drew, again, a line parallel, I would get the set of all space-time events that are simultaneous with 4 seconds. So what I'm going to do is I'm going to draw a line parallel to the x prime axis. Again, I'm worried I'm going to mess this up. So this tells me that that is my reading for event E, and let's see, it's between 4 and 5. Maybe we'll call that 4.2 seconds. So this is the same physical event in space-time, and as we've seen throughout the course, different observers or observers in different reference frames will record different space-time coordinates for the same event. And here we see in this graphical construction how to read that off from just one space-time diagram. It's one space-time diagram that has two sets of axes on it. In the next video or two, we'll derive a way to come up with a formula for this, so that like if you tell me these unprimed numbers, I could tell you the primed numbers, or vice versa. But I think this gives us a way to picture what's going on, and maybe is more likely to lead to some sort of understanding or intuition. So following this video is a quiz where you can practice the stuff, and then we will derive a formula that does the same thing as this graph.